Hi everyone, welcome again. Let us continue on our topic. We just looked at the analytical method of a member subjected to a direct stress in one plane. Let us look at some problems, numerical problems that should give us a bit of confidence on how to address these. Problem 3.1 from the textbook: a rectangular bar of cross-sectional area 10,000 mm squared is subjected to an axial load of 20 kilonewtons. Determine the normal and shear stresses on a section which is inclined at an angle of 30 degrees with normal cross-section of the bar. Now let us look at what is given. The first thing, the cross-sectional area is given. (10,000 mm squared). The axial load, in our case, load P is given, which is 20 kilonewtons. Let us convert it into newtons so that we have consistency of units all across. And then angle of the oblique plane. So in our case, EF and FG are the two planes. So the angle that FG makes with EF is given as 30 degrees. So theta is 30 degrees. Now if I draw a diagram, I have my plane EF and FG, and this angle is 30 degrees. All right, what is he asking us? He's asking us to determine the normal and shear stresses on a section on FG. So it's a now first let us find out what is the direct stress on section EF, which is sigma is nothing but P by A. Straight over formula, P is 20,000, A is 10,000. So your P by A becomes 2 Newton per mm squared. Now if we assume that sigma n is your normal stress on the oblique plane, we know the formula of sigma n is sigma cos square theta. And then you substitute the values of sigma. Sigma is 2 times cos square theta is cos square 30. Now solving this, you get cos square 30 is 0.866 square, and then when you resolve it, you get 1.5 Newton per mm squared. This is your sigma n. This is your first answer. And now the next section, he's asking you to find sigma t, which is the tangential stress. So tangential stress, we know the formula is sigma by 2 sine 2 theta. So substituting in this, you get 2 by 2 sine 2 times 30. And then solving for this, sine 60 is nothing but 0.866 Newton per mm squared. This is a straight substitution in our formula. Now let us look at let me just put in another. Let us look at another example from the textbook, example 3.4. Two wooden pieces 10 centimeters in the cross section are glued together along line AB as shown in figure 3.3 below. What maximum axial force P can be applied if the allowable shearing stress along AB is 1.2 Newton per mm squared? So let us first record the information that is given. It is given that the two pieces or the cross-sectional dimensions are given. So we can find out the area of the cross-section. Becomes 10 times 10 or 100 centimeter square. Now converting this into mm, it becomes 100 times 100. It becomes 10,000 mm square. So that our answer will be Newton per mm square. Now he is given you the maximum allowable shear stress. So he's given you sigma t as 1.2 Newton per mm square. Now if you look at the angle of line AB with the axis of axial force, he's also given you the angle as 30 degrees in the diagram. So, but that is not theta. Theta will be your angle across your plane. So if you look at this, in a right angle, you've got 30 and you've got 90 minus 30. So theta will be equal to 90 minus 30, which will be 60 degrees. Now, moving on. I mean, if we consider P to be the maximum axial force, and sigma be the maximum allowable stress, I mean, we can use the equation for sigma t, which gives you sigma by 2 sine 2 theta. We've got theta, so, and we've got sigma t, so 1.2 is equal to sigma by 2 sine 2 theta is sine 2 times 60, or sine 120. Solving for this, you get sigma is equal to 1.2 times 2 by sine 120 is equal to 2.4 by 0.866. You get 2.771 Newton per mm square. So this is your sigma. Now he's asking you to find out maximum axial force, P. Now P is nothing but stress in the direction times cross-section area. So P is nothing but stress times area. So your stress is 2.771 times 10,000. So that gives you 27,710 newtons, or 27.7 kilonewtons. Wonderful. So these are just some of the simple ways you can address the numerical problems based on that. So it's mainly taking us back to the formula, and that's exactly what we'll keep recording in a sheet and for future reference and subjecting it to memory. We'll continue with the other analytical methods in the next video. And yeah, I wish you all just keep studying hard, and yeah, good luck.